Good day everyone. Welcome to another video tutorial. Today we're going to tackle about equation of circles with inequalities. Given the equation of a circle with a center at 0, 0, or the origin and a radius of 5, it would look like x squared plus y squared is equal to 5 squared. And we can simplify that to x squared plus y squared is equal to 25. This is the equation of the circle, having these properties. Now, when we say the word equation, the present of equal symbol is in there. So meaning that any point that you could substitute on x and y that would equal to 25 will be a point that lie on the circle. So in this case, we'll be tackling about the inequalities of the circle. So if any point like this is a solution that makes this equal to 25, then this will be a point on the circle. But if any point that you substitute here that would make it greater than 25, then that point is outside the circle. On the other hand, if the point that you substitute to x and y becomes less than 25, this will be found inside the circle. When it is greater than or equal, it's just mean that it could be found on or outside the circle. If it is less than or equal, it could be found on or inside the circle. So let's see the graph of the first example. So if it is on the equation of the circle, the circle is drawn to the graphing paper with a solid line. Okay, so that is how we graph the circle. We find the center, 0, 0, and we find the radius that is 5, 1, 2, 4, 5, and we draw the circle. Because all of the points that pass through this circle will satisfy this formula. If the points could give a value that greater than 25, for example, is this point. This is 5, comma 4. If we substitute 5 here, 5 squared plus 4 squared, so 5 squared is 25 plus 16, that is 41. 41 is greater than 25. So this satisfies these inequalities, meaning all this shaded region would satisfy these inequalities. As you can see, I created a broken line here because it states that the boundary of the points is this one, meaning broken line because the point that will pass through this line is not included in these inequalities. When it is less than, if you choose any points in this shaded region, meaning inside the circle, these points will satisfy these inequalities. Let's say for example 1, comma 1. So 1 squared plus 1 squared is less than 25. So 1 plus 1 is less than 25. So 2 is less than 25. So this satisfies these inequalities because 2 is less than 25. So therefore, all of the points here inside the circle are part of it. Again, the boundary is broken line because all the point that pass through this line is not included in these inequalities. If it is greater than or equal, then therefore all the points that pass through this circle should be included. That's why it is written in a solid line. Same as with this one, all of the point inside and the points on the circle. Now let's graph the following inequalities. Again, you can say these are the same center. The center is 1, comma 2, and the radius is 3. All the things that differs from them is this is point on the circle, outside the circle, and inside the circle. So let's see the first one. So we know that the center, and that is how we graph it. The next one, letter B. See, same center and same radius, but we need to have a broken line, and let's shade all the outside region. That's how we graph this one. And lastly, this one is less than the radius. That's why all of the shaded region are found inside the circle with the broken boundaries. Another different example of problem is this. Which of the points 2, 3, 8, 2, and 5, 3 lie on the graph of this circle? So this is the circle. Which of the following points lies on the graph of the circle? So how can we do this? Should we graph the circle? Maybe we could do that. Or we could just substitute or test all the points in by substituting. So if we substitute 2, 3 to x and y's, okay, simplify it, that would give us greater than 20. So it's greater than the radius. Therefore, this point is outside the circle. Let's test 8, 2. If we substitute that there, 8 minus 7, that is 1. 2 plus 1 is 3. 1 squared is 1. 3 squared is 9. That is 20. And that is 10. 10 is less than 20. Therefore, this point lies inside the circle. And let's test 5, 3. We substitute it. We have 5 minus 7, that is negative 2. 3 plus 1, that is 4. Negative 2 squared is 4. 4 squared is 16. So 4 plus 16 is 20. Since it is equal to 20, therefore, this point lies on the circle. So the answer for this one is 5, 3. So this is all for the inequalities of circle, the equation of circle or circle inequalities. I hope you learned something from today. Just watch out for my next video on the general equation of the circle and to answer problem that involves inequalities in the future. So that's all for today. Bye and thank you.